Well, in this section, I want to look at aggregate clauses. This is stuff you're probably already familiar with in using things like Excel, and you may already be used to it using regular GIS packages as well that also allow us to create and find results based on aggregates. An aggregate is basically a function that calculates the total value of a group of values, and it has mathematical operations like average, count, min, max, standard deviation, sum, variance, and so on. So let's look at a couple of these. We're going to camp back out on those states again to look at the obesity values. So let's come back into our query result here, and I'm going to remove this one. If you already have a query result, you can then just again click the update statement and then say select star from states. Let's execute that. That's done. We can update it. So with these query results, I now have all the states, and we can color them in with obesity values. And you know what, why don't we do that? I think that's going to just make things a little nicer. So let's look at, say, the 2009 obesity values. We'll look at graduated values, the column. Let's take obesity 2009, and sure, we'll do equal interval. That's fine. And then hit apply. Okay, so you can see where the higher and the lower obesity values are. So let's again look at some of these aggregates. Now I want to select the standard deviation of the obesity, call it STDEV, and the average. Okay, now these are aggregate clauses. It's taken all 48 states and it's given me the average obesity and the average standard deviation. I can't get a geometry here, right? Because what geometry would you get? Standard deviation is one value that comes from many values. Average is one value that comes from many values. So right now, let's hold off the idea of making a map. We will do that in just a moment. So let's go back. So that gives me the average and standard deviation. I can also, let's actually create this one here. We're going to use both of these commands, or these queries, and I've got a union all. So what the union all is going to do is select a particular resulting table, which I have here. Okay, that gives me the year 2009 and the standard deviation, or the coefficient of variation that we looked at earlier in this class. Here's one for 2000, and we'll execute that. So the union all lets me grab all of them. So we can do the same thing for 1995. I won't bother doing that, but you can see we can then put one on top of the other. And you can see the coefficient of variation is about the same. We haven't had a lot of variability within the data set itself over time. So let's look at something like select min OB 2009 from states. So again, this is an aggregate clause. It's getting me the minimum value. There's a 0 because I think we have one blank value about where OB underscore 2009 is greater than 0. There we go. So that gets me the minimum value. We can go to the TC parcel again too. Select average ASMT from TC parcel. And we'll execute that. And we can also say numeric, : money. That's a little better. So $620,000 is the average assessment value. And have it where prop class is equal to residential. And we can change that to commercial. Right? And we can change that to forest. Wow, if I do this, I'm going to be here for quite some time, right? This is going to take me a long time, you know, and I can do that union all, right? Union all. And we can come in here and say commercial. All right, so now I've got both of these. But you can see how cumbersome that would be. So that's why one of the cousins to the aggregate clauses is the group by clause. And a group by statement performs an aggregate computation on the data, and it groups the computations by one or more columns. So they can include summations, averages, counts, etc. So a single statement with a group by clause can accomplish what might require a couple of pages of code and lots of for loops and while loops in order to get that written and presented. Let's look at this one. So we're going to select the sum of the acres, and we'll call that sum acres, and the prop class from TC parcel and group it by prop class. Now again, I can say select sum acres from TC parcel. That's easy enough. And we'll execute that. Okay, and we can also change that to assessment as well. Oh, I spelled that wrong, so we'll leave that for now. Actually, no, I just didn't highlight it. There we go. All right, and we can again colon numeric. But what I want to know though is what is the acreage based on the property class? So the group box is going to say, oh, you want sum and you want the property class, so we will bust it out for you. Best way to do this is just show you the result. And again, I can say numeric colon money, and now I've got the sum of, well, it's not sum acres, sum, yeah, that's ASMT. Let's make it that way, ASMT. So this is the sum of the assessment for each of the land use or the property class categories. Let's go back to our original one from before. Now we can do the sum of the acres and order by sum acres. There we go. So industrial has the least acres as a class. Now this is taking all of the property parcels that have industrial as their property class and adding it up. So, and what we've then done is then we've busted it apart. So you can see residential properties have the most acres. I can also add a few of these together. I can say the sum of the assessment as sum ASSMT. So notice this is also an aggregate. I sum the acres, I sum the assessment, and I've got the property class. And I can also use count star as num props, right? We'll call that number of properties. And there we go. So there are 107 parcels that are industrial. Let's see what the residential is. There's 24,000 properties that are residential. Here's another query I'm going to just show you really quickly because again I want to impress upon you how easy this gets to be. I might not be interested in the whole term residential. Maybe I just want that very first letter. So here I can group it by the left-hand character in the string. So now I get V, R, I, A, and so on. So we can start to play with those text strings as we did earlier in the class. So all these things begin to join together and converge. Okay, I'm going to jump ahead really quickly. And I am sorry about that we're not going to actually dive into this. We're going to dive into it a little bit later in terms of how the spatial operations work. So this is ST intersects. We saw that early on when I was showing you the data types. I can see where the parcels intersect the flood zones. That's great. And I can see where the property class is between 200 and 299, or the PC. So that's those residential properties. And they're also not blank. And I'm going to group it and order it. So these are the properties that are touching the flood zone layer. Maybe we can come back in here. Let's turn this guy off. Let's zoom to the flood zones. So you can see some of the flood zones that are in here. All right, and let's turn the watersheds off. And we'll zoom in a little closer. Okay, so now you can see some of the flood zones here in red. And we're going to find those properties that are in the flood zone. And in this case, I just want the residential ones. So let's execute that. And we'll give this a second to complete. That's done. So I'm getting the property class and the zone. And again, I probably should do numeric, money. Let's run that again. So this is telling me 210, the single family residential, is in the A zone. It's $88 million. There's 200 million that are in the AE zone, and there's 204 million that's, or 215 million in the AE zone, 204 million in the X500. Here's the two-family residential. There's about 5.9 in the A zone. So you can see we've been able to break this up, and we look specifically at the properties that are in the residentials. And I could say and zone is equal to AE. Now I want to know just the ones that are in the AE zone. We'll execute that. So this tells me the sum of the assessment in the AE zone for single family, two family, multifamily, and so on. So all the different land use types. And again, take a look at what our grouping is doing. I'm grouping it by the property class. That's why I'm getting summations by the property class and the zone. So a 280 in the AE, a 280 in, well, these are all AEs now. So a 220 in the AE, a 210 in the AE, and so on. So we're grouping all of these together. So this is really powerful stuff, and it looks very English-like, right? And think about how we have to do that in a GIS using some special wizard. It becomes a lot more difficult. All right, let's have some more fun here. And I'll skip this one. Let's go now to this query. And here what I want to do is use STUnion. What's that? STUnion is actually an aggregate clause for geometry. It's going to union them together. This is an extremely important concept, right? We've been using aggregate clauses like average, standard deviation, and counts and sum because these values are just numeric values. Well, if geometry is just another data type, like numeric is, then I should be able to do aggregate clauses on those as well. Let's do another one again, and let's include the STUnion, which is an aggregate clause for we'll come back in here again. And remember, just like we worked on the average and standard deviation, those are all aggregate clauses for numeric data types. So we have an aggregate clause for geometry data type, and union is one of those. So what that will do is it's going to create a unionized or a similar geometry for, in our case, all the property classes. So what I'm doing here is I'm getting the geometry, the property class, the from the parcels as A and the parcels as B, where they touch. So where two parcels touch, I want to make sure that's the case. Also, I want to make sure where the two parcels have the same property class. I want them to be part of the selection. And I also want to make sure it's not the same parcel touching, because what I've done here by saying TC parcel as A and TC parcel as B, I'm pretending as though there are two different tables when in fact there's one. So I just ran this outside of the video. It takes 82 seconds. So you can, that's because I'm working on a laptop. You may have a much faster computer. It might run faster. But let's take a look at what this looks like. So I'm going to hit load, and we'll take a look in a second. So here you can see the result of that query, and notice we have these groupings, because what this represents is a merged version or a dissolved version of our layer. This is actually kind of slow in QGIS, and the reason is every time we do something on the map, it goes back to the query. So I can come in here and then say export, and I'll save the features, and we can save it to an ESRI shapefile. I'll put in C temp merged par, and we'll hit OK. So we'll let that thing write itself out. So that now completed, and we can zoom in a little bit closer. So let's come in here. We'll turn off the query result. We don't really need that. And notice you have all these property parcels here. But now when I click on this layer, you'll see this is residential, and here are all the residential properties. This one here is all commercial properties. So again, you see where they were all merged together. So that's the way we can actually perform a similar kind of aggregate clause, but with a spatial operation. Let's just end it right here. I'm going to do one last one because we're going to start jumping into our spatial operations next. So this is a good way to start this up. And this is where we're kind of putting everything together at once. Here I'm going to compute the average assessment, the sum of the assessment, and the property class from the parcels and the flood zones where the assessment is between 100,000 and 200,000 and the parcels intersect the flood zone and the property class for those parcels is either residential, commercial, or vacant. And then I'm going to group it and then order it. This is one of those queries. Look how quickly it ran. How would you do this in a traditional GIS? So you're going to have to perform a whole bunch of intersections first. Then you're going to have to provide some or provide some select by locations, or excuse me, select by attribute, then select by location. So here's one select by attribute. Here's another select by attribute. Here's a select by location. And then you're going to have to use some kind of a summarize tool within the GIS to get me all of these values. And if I wanted to create the coefficient of variation, we can divide the STDEV we'll get the standard deviation of the assessment and we'll divide it by the average. We won't run that now, but again, you see the idea that we can at least start to add other functionality. And again, that gets back to in the GIS, we'd have to create another column. In fact, I'm going to do that. Let's do STDEV, the assessment, as STDASMT. So we'll run this. So now I have my standard deviation, and here's how I think through some of these problems. Select star from, and then I can create this as a table as T1. All right, that's going to get me the same results, but now I want to say select star and STDASMT divided by AVGASMT as CV for coefficient of variation. So adding this as another column is just as simple as what we did. And here you look at the coefficient of variation. Which ones are the more volatile for the ones that are between these assessed values and these different land use types that are in the flood zone. So get ready, we're going to jump into the spatial stuff next. This is going to be a much longer section where we're going to get to try a lot of fun spatial type operations.